we've already seen that the gradient vector is always perpendicular to the tangent line of the level curve. We've already seen this. So now let's extend it to 3 independent variables. So when you put a constant into here, this thing here will then give you a level surface. Up here it's a level curve, it's just a line. Down here it will be a surface. So our next task is to come up with the equation for this tangent plane. Up here we can come up with the equation for the tangent line. Down here we have to come up with the equation for the tangent plane at this particular point. So in this video I'm going to give you a reminder of an equation of a plane, and then in the next video I will give you a working example. So remember, with an equation of a plane, this is just a reminder, we've already done this before. When you have 2 vectors here, the normal vector, if you can somehow come up with the normal vector, then you can describe the plane, because this plane here is always at 90 degrees. It's always at 90 degrees to the normal vector. So this thing back up here, this grad f here is always perpendicular to the plane, so it's always at 90 degrees. So in a way later on we can work out grad f, which will mean it's a normal vector. So down here, once you've got your normal vector, you can describe the plane. So remember, let's select a general point on. Let's select a general point. This point here is not on the plane, so it's a general point. So it's going to be x, y, and z. So you can think of this as being at a location of x, y, and z, or you can think of it as being a position vector from the origin. You've moved, so it's a position vector straight across here. This point here is any point, general point, any point, sorry, x0, y0, z0. So you can think of this as being a location in 3D space, or you can think of it as a position vector. So you've moved across in the x direction, and then moved across in the y direction, and then up. So you can think of it as being a position vector or a general point in space. Well, let's look at this point here. Well, to describe the plane, we require that this vector here must be orthogonal to the normal vector. It must be at 90 degrees. If you're on the plane, then you will be at 90 degrees. You will be at 90 degrees. If you let's look at this point here. This vector here will be at 90 degrees. So to describe this plane, we will need to demand that the normal vector and any general point, any vector to the general point must be at 90 degrees. Well, you demanding something to be at 90 degrees is like you demanding the dot product to be 0. So let's try and figure out this vector here. What is this vector here? Well, at the moment this location here is x, y, and z. So that's our position vector. This point here, let's imagine this as being a position vector here. So how do you, if you're an ant, how would you get from here to here? What is this vector here? What is this vector here? So if you're an ant, you have to walk backwards. So starting from here, starting from here, you have to walk backwards here. So that would be minus this thing here. It would be minus x0, minus y0, and z0. So you have to walk backwards, and then from here, then you can move to x, y, and z. So this vector here is really the combination of these two, but I'm going to tidy this up. I'm going to imagine it as x minus x0, y minus y0, z minus z0. So this thing here is our vector from here to here. Well, we need to demand that this vector to be orthogonal to this. So we need to demand that the dot product of our our vector and our normal vector n1, n2, n3 to be equal to 0. So if you make this demand, then you will describe the plane, because if you're not on the plane, then these two vectors won't be at 90 degrees. If you're on the plane, if the dot is on the plane, then it will be at 90 degrees. So making this demand will be you describing the plane. So when you come to multiply this out, the dot product will be this times this, so it would be n1 and then x minus x0 and then plus this times this, that would be n2 y minus y0, and then this times this, so that would be plus n3 z minus z0. You need to demand that it equals 0. So this is the way we would describe the equation of the plane. We've already seen this before. I've already done many videos on this, so I'm expecting you to know this. So now in the next video I will give you an example of how we can use grad f, which will be this vector here, to describe the tangent plane.